Bismillahirrahmanirrahim. Assalamu alaikum. My name is Meerwein and I am from the Department of BS Chemistry. My ID is 004 and this is the semester of 3rd. Today I'm going to talk about my presentation topic and which is of 5 named reaction. And these are the name of reaction: Meerwein Ponnodorf Verley reaction, Ball-Schemans reaction, Schwarz reaction, Sandmeyer's reaction, Ellington reactions. So at the very first, I'm going to talk about the Meerwein Ponnodorf Verley reaction. It was named after Hans Meerwein, and this is the reaction type of oxidation redox reaction. Redox reaction is basically of oxidation and reduction reaction. It was discovered by the Meerwein and Schmidt and separated by the Verley in 1925. In explanation, we're going to talk about both scientists, Verley and Schmidt, Verley found that the mixture of the aluminium ethoxide and the ethanol could reduce the aldehyde to their respective alcohol. Ponder applied the reaction to ketones and upgraded the catalyst to the aluminium isopropoxide in isopropanol. In the reduction of the carbonyl compounds, we can see that MPV reduction or Meerwein-Ponnodorf-Verley reduction in organic chemistry is basically the reduction of the ketone and aldehyde to their corresponding alcohol utilizing the catalyst aluminium alkoxide. So what are the advantages of this MPV reduction? Its highly chemoselectivity, its use of the cheap environmentally friendly metal catalyst. This is an organic redox reaction in which we can see the oxidation and reduction simultaneously. In the general reaction, we have ketone and alcohol, and which can occur in the presence of the aluminium isopropoxide catalyst, and we get a respective carbonyl compound and their respective alcohol. And the mechanism of the Meerwein-Ponnodorf reaction. We're going to talk about its steps, how this mechanism going to occur. The MPV reduction is believed to go through the catalytic reduction involving 6-membered ring transition state as shown in this figure. It's basically start with catalyst aluminium alkoxide. Then the carbonyl oxygen is coordinated to achieve the tetrahedral coordinated aluminium intermediate. Between the 2 and the 3 intermediate, the hydride is transferred to the carbonyl compound from the alkyl ligand by the pericyclic mechanism. So at this point, new carbonyl dissociate gives the tri-coordinated aluminium species. Finally, the alcohol from the solution displaces and reduced to the carbonyl to regenerate the catalyst 1. This is the catalyst and this cycle goes on and the mechanism goes on. This is the catalytic cycle of the Meerwein-Ponnodorf-Verley reduction. In the explanation, we're going to talk about every step that is going to happen in the mechanism. Each step in the cycle is reversible and the reaction is driven by the thermodynamic properties of the intermediate and the product. This means that the given time, the more thermodynamically stable product will be favored. Several of the mechanisms have been proposed for this reaction. These are radical mechanism and the mechanism involve aluminium hydride species. The explanation of the Meerwein-Ponnodorf reaction includes the commercial aluminium isopropoxide is available. The use of it is often required catalyst loading from 100 to 200 moles percentage. This hindered the use of the MPV reduction on scale. The recent work has shown that aluminium alkoxide made in the situation from the trimethyl aluminium reagent have far better activity requiring as little as 10% loading. The activity difference is believed to due to the large aggregation state of the commercial available products. Several side reactions are known to occur. In the case of ketone and especially aldehyde aldol condensation have been observed. Aldehyde have no alpha hydrogen, can undergo tight reactions. Finally, in some cases of alcohol generated by the reduction can hydrate it, giving alkyl carbon.